Always a good day. We have equations of lines to write. All right, let's go through this real quick. So the first question says the graph of the line n is shown, and they want to know which number is closest in value to the slope of the line. It's a little hard to see, but whenever you're trying to calculate the slope of a line, you need 2 points, 2 clean points. And by clean points, I mean I'll use this example right here. These are examples of clean points. A clean point is a point that lands directly on the corner of one of these box grids. So these would be 2 clean points. A point that isn't good enough for finding the slope would be something that would fall in the middle, where it's kind of hard to determine what the coordinate of that point is. So this point is not a good one to use. You don't want to choose one of these points, because if I ask you simply to tell me what's the coordinate of that, you probably would have to take a little bit of an estimate, and while you might be close, you're not looking to be close, you're looking to be accurate. So these types of points, these are okay. So just keep that in mind. Now, most of the time, when you're trying to find a point, I try to find a point that I might be able to use later on. So while these are good to find slope, most of the time I try to see if the y-intercept is a good point, because if I'm trying to write the equation of a line, I can use this when I figure. So like this equation would be y equals, let's see, 3x minus 1, and the minus 1 comes from that point right there, which is the y-intercept. So if I can do that and have one of my points that I use to find slope also be the y-intercept, it's kind of like a 2-for-1 deal. So I'm going to always try to do that, and every once in a while you'll encounter a graph where you can't do that, but it's not really a big deal if they're just asking you for slope. So when I look at every problem, I'm going to try to do that just to make my life a little bit easier. So let's look at the actual problem. I'll zoom in a little bit so you can see. So here is your graph. If you look at it, I'm going to choose 2 points, and like I said, if I can choose the y-intercept, I will. And in this case I can, and the y-intercept and this clean point is over here. And then I need another one, and so like I know this graph is really small, and I'm zooming in as best as I can. You're just going to choose what appears to be the next best point. And this one is, if you look carefully, it's right here. Okay, and what you're trying to do is you're just trying to calculate your rise over run. So I'm going to start, I usually start from the point on my left, or closest to the left side of the graph. So I'm going to go up 1. Okay, so I rised, or rose, went up 1, and then I'm going over 4, or the run is 4. The only other thing to check is it a positive or negative slope? In case you forgot, I usually do this, or tell my students to do this. I always look, I read graphs and I read lines from left to right, and as I'm looking from the left arrow of my graph to the right arrow of my graph, I notice that it's kind of trending upwards in the direction of my positive slope. So if this were to go on forever, or beyond this graph, it would eventually rise to the top and touch this plus. So this is a positive slope. Okay, so as you're going from left to right, it's going upwards. So I'm looking for a positive 1/4 in my answer key, and here it is. Another good test-taking strategy is if you can identify the sign of the slope before you even calculate the slope. If I did that first, I would have been able to eliminate A and B instantly because they're negative. So that's another test-taking strategy that you might want to apply when you're sitting for any exam. It's not just SOL particular, it's any math exam that deals with functions and graphs and lines. Something to think about, even as you move on into higher level math. Let's go down to this one right here. It says, what equation best represents line M? And so this is kind of like what I was explaining earlier. To find an equation, I'm going to look at it in slope-intercept form, y equals mx plus b. So I need a slope, which we just practiced doing. This is my slope. And I need a y-intercept. Now when I'm finding my slope, I need 2 points, and if I need to pick 2 points, if I choose the y-intercept as one of the points, it kind of takes care of that requirement immediately. So if this is a multiple choice test, let's just start by our test taking skills here. All positive slopes will tend to go up and to the right, and all negative slopes will trend down and to the right as you're looking from left to right. So it's just like reading typically from left to right. Here are your 2 arrowheads for your line, and I always just compare them. I just kind of like trace the line, and as I'm tracing this line, I see that my line is trending up and to the right. So this is going to be a positive slope, which means if using the multiple choice options in my favor, positive slope means that this negative 3x, that negative slope, that's not an answer. This negative 1/3 x, that's not an answer. So I'm down to 2. Let's go see if the y-intercept can help me out. I need to choose 2 points for the slope, so let's try to use one of them as the y-intercept. The y-intercept is -4, so I'm looking for an equation that ends in -4. Okay, so they didn't help us narrow these options down. There's nothing wrong with that. What I'm going to do is I'm going to find another clean point and calculate the slope and determine if it's 1/3 or 3. Here's another good point right here. And remember, slope, or m, right, is rise over run. So let's just calculate it real quick. I'm going to go up 1, so it's 1, and it's over 3. So it's 1 over 3. And we already know it's positive because we determined that earlier, so it's 1/3, so that's choice C. Faded. There we go. Alright, let's move on to the next question. Okay, so this question up here, just zoom in so we can see only that question. Okay, so this question says, what is the slope of the line represented by this equation? Now this is in standard form, this is not slope-intercept form. If it was in slope-intercept form, this would be relatively simple to do. So we're going to put this into slope-intercept form. So I'm just going to solve for y, which means I want it to look like, I tell my kids I want it to be a y equals equation. Once you do that, and if you do it correctly, the slope will be very easy to pick out. So I'm just going to rewrite this over here so I have some workspace. Okay, 3x plus 5y equals -7. I'm going to start by getting rid of the 3x, so I'll subtract it from both sides. Remember, you have to do everything you're going to do to both sides, and so this will be 5y equals -3x minus 7. You want to put the x first. It's just typically how it's written. It's the proper way to write it. And now I need it to be y equals. So not 5y equals, but y equals. So what I'm going to do is I'm going to divide everything by 5. And then I'm just going to simplify anything that can be simplified. And if it can't be simplified, I'll leave it as a fraction. 5 over 5, of course, cancels. That's why I did that. None of the other terms can simplify, so my equation, I'll just rewrite it, is y equals -3 over 5x, or 3/5 x, minus 7/5, or minus 7 over 5. And so this coefficient for x is your slope, so our correct slope would be -3 over 5. And that's our answer. This is not a 1, by the way. That's just a line, so don't get tripped up by that. The answer is -3 over 5. Cool. Okay, moving on. This one says, which equation represents the line that passes through the points -4, 4, and 8, -2? So let's look at our option choices. Clearly this is written in slope-intercept form, as it's all y equals, y equals, y equals, y equals. So what we're going to do is we are going to first find the slope. Now let's just write down the slope formula. Slope, or m, equals y2 minus y1 over x2 minus x1. When you're doing these problems, it doesn't matter which one is x1 or x2 or y1 or y2, as long as you're careful to label it. So when I do these problems, and I always tell my students to do this, from this area right here, I'll label these points immediately. Some people like to do shortcuts or feel confident enough to go right into the math, which is fine. But I mean, if you're going to be sitting in a test or sitting in a class or sitting at home doing work, I'm pretty sure you have about 15 seconds. It's not even 15 seconds, 5 seconds to just do this. I'm just going to call this x1, y1, x2, y2. There you go. It takes 4 seconds. Shouldn't be too hard to do. From here, I'm just going to plug in. So this would be negative 2 minus 4 over 8 minus a negative 4. Now sometimes you get this minus a negative. Sometimes it's completely unavoidable. It's not a big deal. Just make sure that you write it carefully, double check. I always double check. y2 is negative 2, minus is part of the equation, y1 is 4, that's good. 8 minus a negative 4, we're good. Alright, so now we're just going to punch this in the calculator, or you're just going to do it, you know, the old-fashioned way. This will be negative 6 over 12. And we can simplify that to negative 1/2. So here is your slope. This is your slope. And I'm going to look at my answer choices right now to see if I can knock a couple out. A is gone, B is gone, and now I'm down to 2 options. So let's find the y-intercept, shall we? What I'm going to do to find the answer to this is I'm going to choose one of these points. I don't really care which one you choose. You can choose the first one at negative 4, 4, or the second one as 8, negative 2. Okay, so now that I have it down between either choice C or choice D, I'm going to have to actually create the linear equation and see which one it is. They both have the same slope, but they have different y-intercepts. So what I'm going to do is I'm going to use the point slope form, and I'm going to plug in my information and see what I get. So you just have to choose one of these points, and we do have the slope right here. So I'm going to write it out first. So the point slope form is y minus y1 equals m x minus x1. The y and the x will just stay y and x, but the y1 and the x1 will be replaced by either this point or the other point. I'm just going to stick with the one that I've already labeled as y1, x1. You can use the other point. You'll still get the same answer if you do the math right, but just to clear up any confusion, I'm going to just use this point right here. So y minus y1 would be y minus, now y1 is 4, so that'll be 4, equals m, which is our slope, which is negative 1/2, parentheses, x minus x1, which is a negative 4. So this is like kind of where things get a little tricky. Just this negative sign has nothing to do with this minus sign. You still need to write a negative 4, so I'm just going to put another set of parentheses, negative 4. Alright, so I'm going to just move up here and just finish my work. So let's do the math here. So y minus 4 will stay y minus 4. Alright, so this will be negative 1/2 x plus 4. Okay, because the two negatives make a plus. Now I'm going to distribute. So this would be y minus 4 equals negative 1/2 x minus 2. And then I'm just going to solve for y by adding 4 to both sides, and I'll get y equals negative 1/2 x plus 6. Plus 6. Woo! Plus 2. Oh my god, plus 2. What was I looking at? Which is choice C. Okay, so let's go down to this one. We basically have 3 lines on this graph, and we need to determine which equation goes with which line. So this is the 3 equations right here, and these are the 3 lines. We have line A, we have line B, and we have line C. So we're going to need to put these all into slope-intercept form, which, in case you forgot, slope-intercept form is going to be y equals mx plus b. Currently, 2 of them already are. These are, but this one is not. Just in case you forgot, f of x could just be replaced with y, if that helps. This y equals negative x plus 6. What I'm going to do to make my life a little bit easier is, if I was presented with this question, I would just go ahead and find these 2, and as long as I do that correctly, the last one should be that one right there. So this is a line that goes through negative 10 and has a slope of positive 5. So let's see this. So this appears to be negative 10 down here. So line A would be this one. That's good. Check. And now we'll see a line with a negative slope that goes through positive 6. 1, 2, 3, 4, 5, 6. So that's choice B. And which leaves this as choice C. So you actually didn't have to convert that into slope-intercept form, but I will, just in case you forgot how to do it. I would add 4x to both sides. 2y equals 4x plus 8, and then I would divide everything by 2, and that will leave me with y equals 2x plus 4, a line that goes through positive 4 and has a positive slope. That would be line C, so I was correct there too. Okay, so let's move down. Let's move down here. Write the equation of a line that passes through the point 4, negative 2, and has an x-intercept of 3. Passes through the point 5, 1, and has a y-intercept of negative 3. Alright, so what I'm going to do is I am going to write down this point. So x-intercept of 3 means that we have a point 0. X-intercept of 3. Point 3, comma 0. Okay, so that's what that means for me. Now, normally they give you a y-intercept, but here they give you an x-intercept. And what that really is in disguise is another point that you can write out. Now, remember, an x-intercept is when it passes the x-axis. X-intercepts are always some number, comma 0. And so now I have 2 points here. I'm going to try to use this space over here. This will be problem A. Problem A. So I can clear this up. Alright, so what I'm going to do is I'm going to find the slope first. M equals y2 minus y1 over x2 minus x1. If it helps, I'll call this x1, y1, x2, y2. And now I'm just going to plug in and find the slope. So the slope will be 0 minus negative 2 over, probably not the best place to do it, I apologize, but hopefully you can read that. 0 minus a negative 2 over 3 minus 4, and that would equal to 2 over negative 1 or negative 2. So we have a slope of negative 2. So I am going to then use my point slope formula, which is y minus y1 equals m parentheses x minus x1, and I'm going to, now this is my slope, right? This is m, so I'm going to use that in any one of these 2 points to just get my equation. So I am going to use the easiest point that I can see, which appears to be 3, 0. So that should be nice. Y minus 0 equals negative 2x minus 3. Y minus 0 is just y, and I'll distribute here as negative 2x plus 6, and that's my line that passes through both of those points for choice A. Question B is a little bit easier. When they give you a y-intercept, what I can do here is, let me just see real quick. Oh no, you know what? I still need a slope, but this is going to be a y-intercept of negative, let's see, 0, negative 3. That's the point. I still need to find the slope, so I'm still going to do my slope formula. So I'm going to just slide down over here, and I will do, I like to write the whole thing out just so that I'm not skipping a step. I'm not trying to be lazy. I don't want to make a simple mistake or lose points on something that's as minor as writing this out. So y2 minus y1 over x2 minus x1, and so I'll just call this x1 y1 x2 y2. Once again, that does not matter. You could have called this point x1 y1 if you want. It won't change your answer as long as your math skills are alright. So this will be negative 3 minus 1 over 0 minus 5. And that would be negative 4 over negative 5, or 4 over 5, because the negatives will cancel out. Okay, and so now that you already know your y-intercept of negative 3, and you already know your slope, you can put this into slope-intercept form immediately. I'm just going to write the answer to the left. Remember, so slope-intercept form is y equals mx plus b. You need a slope and you need a y-intercept. I have a slope and I have a y-intercept of negative 3, which was given to me, which is really generous. So now I just got to piece it together. Y equals, now comes the slope, 4/5, or 4 over 5x, plus, in this case it'll be minus because this is a negative 3 intercept, so it'll be 4 over 5x minus 3. And that's my answer for B. Alright, last question here. Which equation represents a horizontal line passing through the point 7, 5? I'll read it again. I guess the screen went dark. Which equation represents the horizontal line passing through the point 7, 5? 7, 5 is just another point on a graph, and I don't really have a graph here to show it to you. However, there's an easy way to think about this. All horizontal lines just go from left to right, and they're flat. They don't go up, they don't go down, they don't go vertical. They're just a horizontal flat line. Every single flat line, such as this one, has a slope of 0. Okay, and so basically that means that the equation is usually, well, it always is, not usually, always, it's y equals some number for every single one of these types of horizontal lines. And that number is always whatever the y coordinate happens to be. So this equation will be y equals 5. That's it. Because what it does is it just goes through 5 on the y-axis, and it just kind of stays going flat through that. So we're looking for y equals 5. Now I already know that it couldn't be choice A or choice C, because any equation that has x equals some number is going to be a vertical line through the x-axis at that number, and we are looking for a horizontal line. So it was going to be either B or D. And so between that choice, you're going to look at the point they give you and find the, remember this, the first one is the x coordinate and the second one's the y coordinate. If we're looking for a horizontal line, it's y equals that. So that's going to be your answer right there. And you can pretty much do that for all of them. They're always going to give you a point, most likely, and if they do, you just got to know which number you're looking for. Alright, thanks for watching.